For example, let's consider the element with symbol X. This element will be located subsequently between its higher value and its lower value, keeping the lower value element on its left hand side and a higher value on its right hand side. For example, if the ionization energy of an element is 1251 kilojoule per mole, it will be placed between sulfur and argon, which have ionization energy values of 1000 kilojoule and 1520 kilojoule per mole respectively. Students, it states that if the element has, for example, 1251 kilojoule energy, and in periodic table there is an element with 1000 kilojoule energy and 1520 kilojoule energy, since 1251 is in between the 1000 and 1500, that is why that element, which is called X element, that will be placed between these two elements, and these two elements are sulfur and argon, because their energies are above and below the given element. Similarly, from top to bottom, if the element Y has ionization energy of 738 kilojoule per mole, it can be placed between beryllium and calcium, because the ionization energy values are 899 and 590 kilojoule per mole respectively. Students, it states that, for example, in element Y, it has ionization energy of 738. We will check the values of certain elements like beryllium and the calcium. Beryllium has 899 and calcium has 590 kilojoule per mole of energy, ionization energy. Since 738 is in between 590 and 899, that is why the element Y will be placed between beryllium and the calcium. Students, it is stated that by comparing the element's ionization energies with the periodic table, we can deduce its position in the periodic table, but this method is not always accurate. This is not always accurate, as there are some fluctuations in the ionization energies due to the nature of the element and its electronic arrangement. Students, here in this paragraph it is stated that although it is very effective method to locate an element or place an element according to its ionization energy, but since there are discrepancies or abnormalities or anomalies in periodic table, that is why sometime it becomes difficult to place that element in the given periodic table. Hence, this is not 100% accurate method. Next topic is the electronic configuration and position in the periodic table by using successive ionization energy data. What is meant by successive ionization energy data? It is the data which is collected when we remove 1, 2 or more than 2 electrons from the given element. If we remove 1 electron and then the second electron, then we call these energies as successive ionization energies. The successive ionization energy value is an index of the valence of an atom. Students, it states that the successive ionization energies, from the successive ionization energy, we can determine the valence of an atom. Either it contains 1 electron or more than 1 electrons. Big gaps show that the next electron is being removed from the lower level. For example, in the case of sodium, there is a big gap of first and second ionization energies. For example, the first ionization energy of sodium is 495 and the second ionization energy is 4560. There is a very big gap, almost 4000 kilojoules. So it shows that the sodium has 1 electron in its outermost shell, and the removal of the second electron is so difficult because the next shell is a complete one. Hence, we can say that the valence electrons in sodium are equal to only 1, because the first electron is removed easily and the second electron is removed with very much difficulty. This indicates that there is only one electron present in the valence shell, and this element must be a part of group number 1 of the periodic table. Similarly, in case of magnesium, there is small gap between the first and second value of the ionization energy, but between the second and the third value of ionization energy there is a very large gap. It states that in case of magnesium, the first and second electron can be removed very easily. There is a little gap between their ionization energies, but the third ionization energy is so much higher. So we can deduce that the two electrons are removed easily, hence there are two electrons in its valence shell and its valency will be equal to +2, while the third electron is removed with very much difficulty. So we can deduce that the third electron is present in the next closed shell of the magnesium, hence the removal of that electron is very much difficult, and the valency of the magnesium is equal to +2. Now we can see that the first ionization energy of magnesium is equal to 735, the second ionization energy is 1445, and the third ionization energy is 7730. You can see that there is a very big difference between 730 and 1445. So this big difference shows that we can remove only two electrons from the valence shell of magnesium, hence it will be located in group number 2. This indicates that the third electron is being removed from the inner shell. It indicates that there is only two electrons in the valence shell which are removed easily, so that element will be or should be a part of group number 2 of the periodic table. Here there is a table, and its table will give you an idea about the successive ionization energies. For example, this is sodium. Its first ionization energy is 495 and the second is 4560. In case of magnesium, the first one is 735, the next one is 1445, and the third one is 7730. So we can say that only two electrons will be removed. In case of aluminium, the first ionization energy is 580, the next is 1815, next is 2700, and the next one, which is fourth one, that is equal to 11,000. This 11,000 is so much higher, and because the removal of the core electron is difficult, hence the fourth energy is very higher, and we can say that from aluminium we can remove only 4 electrons. Similarly, here we can see that sulfur has 6 ionization energies which are close to each other, because the sulfur has 6 electrons in its outermost shell. But you will be astonished that 8490 is its 6th ionization energy, while the 7th ionization energy is 27,000. 27,000 is a very big amount of energy. This is because the removal of 8th electron, the removal of 7th electron from sulfur is so much difficult, because it contains only 6 electrons in its outermost shell. Chlorine and argon, you can see that these electrons, these elements have 7 ionization energies, because they have 7 electrons in their outermost shell, and argon has 8 electrons. The removal of the 8th electron of argon is too much difficult, because it has already an octet. Thank you very much for watching this video.